For example, if I want to find an angle here, I can see from this that C is my largest angle, right? Solve for your largest angle first. Is there ever a case when the cosine has an ambiguous case? Let's think about it. So we have our unit circle. Let's think about why the sign has an ambiguous. So who can tell me why the sign has an ambiguous case? No, I don't have two unknown variables. I only have one. Any other ideas? There's a missing side. Yes. What does that have to do with it? It could be two different angles, because the reason it could be two different angles is we're solving for the inverse. Right? We're always solving for the inverse. So when we solve for the inverse, it's literally just giving us one solution, and that solution is always going to be in quadrant 1, because it can't be negative, and the inverse sign is only defined between minus pi over 2 and pi over 2, right? So the inverse sign is only in these two quadrants. So it would have to give me, because it's a triangle, it can't be negative sign, it can't be a negative angle. So it's always got to be in quadrant 1, right? Does everybody understand what I'm saying? Okay, but there could be another angle that we didn't solve for that is exactly the same in quadrant 2, but the inverse won't give it to me because the inverse is 1 to 1. So we find it ourselves. Yes? So far so good? So my question to you is, will I ever have an ambiguous case for cosine? So to answer that question, you have to look at where the cosine is defined, right? So where is the cosine defined? Inverse cosine, I'm sorry. Okay, so all the questions that I'm asking you, you really need to have down before the test happens, just to let you know. So the inverse cosine is defined between, the range of the inverse cosine is from 0 to pi, right? So if I'm in quadrant 1, I'm positive, but if I'm in quadrant 2, I'm negative, aren't I? So I can't be in quadrant 2. You have a question, Kirtan? Okay. So I know for the inverse cosine, the answer when I put in the value and I get the inverse cosine, also it's going to give me a solution in quadrant 1 because quadrant 2 is a negative value. Oh no, that's not true. I just lied to you. It could give me an answer in either one of the two quadrants, depending on whether or not it's positive or negative. And the angle, even the angle is here between 0 and 180. That's fine, right? But there's no ambiguous case because if it's positive, then the the other angle that represents it would be here in quadrant 4, which is way over 180 degrees, or it would be in quadrant 3, which is also over 180 degrees. So for the law of cosines, there's no ambiguous case. We will actually get the exact angle, and the one and only angle. Does that make sense? Do you understand what I said? You do? Okay, good. How about anyone else? You don't? Okay, let me try again. So, no, it's not better. It's just understanding log signs. You'll probably use log signs more than log cosines, truthfully. So, Michael, we have our unit circle, right? Oh, my pen's doing its weird thing. Hold on. Okay, good. So I have my unit circle. And where is, do you have your mic, keep your mic on, Michael? The easiest me, because I know you have one.
Yeah.
Oh, perfect, thank you. So remember that we said that the range of the inverse cosine is from 0 to pi.
Yeah.
Okay, so that means I have a solution for inverse cosine that's in quadrant 1 or quadrant 2. So I know that it's, well, let's just use instead of 0 and pi, we'll use it's between 0 and 180. Does that make sense?
Yeah.
Okay, so now let's say I get a solution in quadrant 1. Okay, so let's say it's, I don't know, 30 degrees. Okay? It's 30 degrees. Well, if there was an ambiguous case, what would the other angle, where would the other angle be that is equivalent to that angle of 30 degrees?
330?
It would be 330, exactly. Well, is it possible for me to have an angle of 330 degrees inside a triangle?
No.
Exactly. So I can't. So if it's positive, I can't have that, right? Let's look at if it's in quadrant 2. If the value that I get is more than 90 degrees, it's in quadrant 2. Let's say it's 120 degrees, right?
Right.
Well, there's an equivalent value to that 120 degrees in what quadrant?
In quadrant 3.
Right, and the angle would be
240?
perfect. 240 degrees. Can I have an angle of 240 degrees in a triangle?
No.
So that's my point, is when you use the law of cosines, there's no, the other angle that you would get, because it's 1 to 1, you have to find the other angle. The other angle that you would use is far out, is way too big for
Right.
And this triangle.
This is the part. I understood what you're saying about this. I don't understand the why. Like, I understand it about sine. I don't understand the why part of it. I got this question wrong on the last quiz, finding the angle with whatever, I don't know.
So you don't
And
for
to
the law
me,
of sines.
I understand that it does. Like, I understand that if the angle that you know is an acute angle, there's a potential for there to be multiple triangles.
Okay.
Right?
But you
That
don't
makes
know
sense?
why.
I understand why, but like when it comes down to why, if the angle is 120 for sine, why it's going to come back 30, I don't understand that on the calculator side of it. Like, why doesn't it just come up as 120 given all these same data points? I don't know.
Okay, wait. I'm with you until you got to what you don't understand.
Oh, okay, I'm sorry. I'm sorry, I was looking at the thing. So if it comes up as 120, like if you have an angle that you're solving for using the law of sines, why does it not show up as 120? Why does it automatically show up as 60 degrees?
Ah, okay, I understand. I understand the question. So...
And why would it, like,
I understand
there's a question on the...
Let me see if I answer. I'm going to answer what I think your question is, and you tell me if I got it, okay?
Okay.
So remember, we have, let's draw a sine graph. And do you remember from pre-calculus, when we had inverses, there was one thing that the inverse function had to be for us to be able to take the inverse of it. Let's not talk about trig functions. Let's just talk about any function that has an inverse. Has to have something. Do you remember?
No. No, I don't.
It has to be 1-to-1. And what 1-to-1 means is it has to pass the vertical and horizontal line test. Remember that?
Yeah.
Okay, yay. Okay, so does this pass the vertical and the horizontal line test?
No.
No. Which one does it not pass?
The horizontal.
Right. So what we have to do is we have to make it able to pass the horizontal line test. So we say, okay, well, then what am I going to do? Let me restrict the domain so that now, hold on. Now I'm only going to take part of the graph and I'm going to ignore everything else. That way, I can make it 1-to-1. Remember we did this with parabolas. We restricted the domain to just the positive side. Remember that?
Yeah.
Okay. So this is pi over 2. And this right here is minus pi over 2. And now is my sine graph 1-to-1?
Yes.
Yes. But where it actually lands on the circle is from minus pi over 2 to pi over 2. So it has to be somewhere between here and here, which makes it somewhere between minus pi over 2 and pi over 2 on the graph. You with me so far?
Yes. In theory, I am. In application, not so much, because it just...
Okay. Okay, well, I'm not done yet.
Okay.
I'm not done yet, but in theory, you're still with me, right?
Yes.
Okay. So now, when I put in a number into the calculator, like I say, what's the inverse sine? Here, let me get a new page. If I say, what's the inverse sine of 1/2, right? What answer is it going to give me?
degrees.
It'll give me 30 degrees in degrees.
Pi
Right?
over 6.
Pi over 6 in radians, either way. But that makes sense, right?
Yes.
Okay, good. Now here's where the trouble comes in. This is fine, you're good. This is this, or pi over 6. Now here's where the problem happens. What if I say the sine of theta is equal to 1/2? And I want to know what theta is. Well, I know theta is 30 degrees, right? But isn't there more than one of those solutions on this circle?
Right.
Where's the other one?
150.
150. Now, I don't care how many times you put it into your calculator, you'll only get 30 degrees back. Because it's 1-to-1, it has to give you the one value between minus 90 and plus 90. The one value between minus 90 and plus 90 is 30 degrees, right?
Yeah.
But how are we going to find the other angle? Because there's another angle here that your calculator can't give me. And obviously I'm giving something that we know because I'm trying to show you, but what if it's 1/25th? We don't know what theta is then, right?
Right.
So we have to get it out of the calculator. And the calculator is only going to give me a solution in quadrant 1. But I know, because I know trigonometry, there's a matching solution in quadrant 2. Did I get it yet or no?
Yeah, it's as good as it's going to be.
Is there something that you don't understand that you can like say again? Because I thought I got you, but maybe I didn't.
No, I think I got it. No, I do get this. I do get this when it comes to this application. When it comes to saying, what is this angle? And I'm going to have to say, no, it's not whatever. It's actually negative, so I can get it in either quadrant 1 or 4. That doesn't, I have a hard time.
Oh, it's not these.
That.
It's actually the, I know which ones, like from Alice, the ones that are like that sine. Okay, I think I know which ones you mean. Like the sine of the inverse sine, or actually I think it's the inverse sine of the sine of, let me make one up, 4 pi over 7. That's what you mean?
Yeah, but I mean, to me, it's all in my brain. It's the same thing going on, and so yes. But either way,
so
to me, it doesn't make sense that.
Let's do this problem. So for this problem, what's the answer? Do you know, Michael?
Well, I think I know that it's negative 3 pi over 7. It doesn't make sense
not,
to me why
wrong.
It's not straight up 4 pi over 7.
It's not.
Then I have no idea what it is.
Okay, so I'm going to explain it. That's why I'm saying I was trying to figure out if you knew. So I'm going to explain it so that you get it. All right? So first I know that I have the sine of 4 pi over 7. First of all, let's say I know these basically cancel out, right?
Right.
And what I'm left with is 4 pi over 7. And what quadrant is that in?
Quadrant 2.
Quadrant 2. Uh-oh. There's a problem because I'm only able to find the solution to the inverse sine in quadrant 1 and quadrant 4. Correct?
Right.
So I have like these little bells going off in my head. Uh-oh, ding, 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 ding. It's not right. So in quadrant 2, is the sign positive or negative?
Positive.
Positive. So the matching value is got to be in quadrant 1, doesn't it?
Okay.
Do you understand?
Yes.
Because they're both positive. So what I need to know is this angle is going to match this angle, right? That's just the way it goes. And this angle is called my reference angle. So what's my reference angle?
Three pi over 7.
3 pi over 7. And that is the answer. Because it's the exact same angle as this one. They're the same. And
it just has to be, for sine and tangent, it just has to be on the left side or the right side. It has to be in 1 or 4.
It has to be 1 or
That's
4, but
basically what
not
I'm
only
hearing,
that,
right?
it can't be 11 pi over 6. What quadrant is 11 pi over 6 in?
4.
But that's not a good answer because that's not, is that between negative pi over 2 and pi over 2?
Okay.
It's not, right? So
Right.
what I need to do is I
Okay.
need to say, well, what's my reference angle? It's actually minus, this is really the same as minus pi over 6. Now, it's between minus pi over 2 and pi over 2. It's a coterminal angle, right?
Okay.
Am I getting close to answering your question?
Yeah. Yeah.
Okay,
I think
good.
I got it.
Thanks for asking, Michael. You are not the only one with
Thanks.
this
I
issue.
really
What?
appreciate it.
I appreciate the question.
I really appreciate it.
Really, thank you for asking. I really, really appreciate you guys asking questions. It makes me know that, like, you are working on stuff. Because that's, I think it's a very valid question. I always wonder why more people don't ask that. Okay. So, any other questions? All right, let's see. Okay, so let's do one more law of sines, and then we'll be done because this is really very straightforward. So remember I said always solve for the largest angle first. So if I'm going to solve for the largest angle first, then I need c squared equals a squared plus b squared minus 2ab cosine of c. And I just plug it in. I have 6 squared is equal to 4 squared plus 3 squared minus 2 times a times b is 24 cosine of c. Let's see, I have 25, 24 minus 24 is 1. I'm sorry, I have 25. So this is 11 equals minus 24 cosine of c. Divide both sides by minus 24 and take the inverse cosine. So I have the inverse cosine of 11 over minus 11 over 24 equals c. So what does c equal? Okay, 117 point, let's just make it 3. So that's C, and I can do this, actually, I can use the law of sines now. And I can solve this, I can say, okay, well, I have the, so I can say the sine of B over 3 is equal to the sine of 117.3 over sine of C over C, and now I can just solve for B. And by the way, if you solve for the largest angle, there is no ambiguous case because I can't have another angle that's greater than 90 degrees. So I'm done with the ambiguous case, and I can just solve for the value of B that I get. Okay? Does that make sense to everybody? Yay. Anybody having some questions or issues? All right, so let's go on. There's really nothing more I can tell you about the law of cosines except there's more laws of cosines. Just ask me questions if you have any. Just do your homework and ask me questions. I'm happy to answer them. And it applies to like side, side, side. We can't do side, side, side with the law of cosines. We can only do it with the law. With the law of sines, we can only do it with the law of cosines. All right. So just in keeping with trying to, do you want me to try to get done like kind of skip through things that I think you already have, or do you want me to go really, really slow? I mean, do you want to get done early, or do you want to stay forever here tonight? And I don't mean that, like, because, I mean, I think I can give you enough quickly that will get you started. So, basically, I'm just going to go through. Does anybody want to do any more law of cosines problems? I guess I should ask that. No? Okay. So, the area of a triangle is, they use K for the area. It's really just 1/2 base times height. Okay? Which you've learned since elementary school, I believe. And there's all these formulas. Of course, they always have formulas. But I don't really understand why you need a formula if you know trigonometry. Because let's look at a triangle. And we can say this is the base. And we know that the area, we'll call it K, just because they do, equals 1/2 base times height. Well, the height is this right here, right? And we don't know the height. If I'm given, I might be given that this is equal to some value. I might be given A, B, and C, but I won't be given H. Yes? But I know this angle. Well, this angle is C, and this angle is A, and this angle is B. So why can't I say that the sine of C is equal to H over A? Right? The opposite over the hypotenuse, which means that H is equal to A sine C. Right? So now I have my new formula that says, depending on what angle I need, this is equal to 1/2. Well, I'm already being given the base, and now I know that the height is A sine C. So this triangle. I can also do it with A. I can say, okay, well, if I want angle A, I can use my trigonometry to find the area for that, area formula for that, right? So if you're a person who loves formulas, there's 3 more, but as you can see, it's exactly what we just found out. 1/2 AB sine C, 1/2 AB sine C. Okay? And so on. How many people would rather have the formula than me explaining the formula? Who wants to just memorize formulas? No, okay. I think they're much better this way. It's like you don't have to memorize as much. Okay. So it says find the area of the triangle for which, well, let's draw it. So let's call this ABC. So that means this is 8, this is 6, and this is 30 degrees, right? So its area is equal to 1/2 base times height. So let's call this the height. So trigonometrically, what's H equal to? Or what can we say with an H? What formula can we use with an H in it? Trigonometry-wise. You can do this one, Griffin. Come on.
Okay, so we want to find A, so that's...
I want to find H. I want to know, how do I find H from this?
We would use the 1/2 AB sine C formula.
1/2 AB. Well, I'm saying don't use the formula. Let's just use trigonometry. That's what I'm trying to say.
Yeah, what about Michael's question right there? Wouldn't it make a right
Yeah,
triangle?
this is a right triangle. That's why I'm saying now we can use our opposite
Okay,
over
so-
hypotenuse. Exactly, Laura. So, well, sine A is not helpful because I don't know what A is. So you put it in terms of C. Yeah, sine C equals, yeah, this is A. So, yes, so sine of C equals the opposite over the hypotenuse, right? Exactly, Laura. Do you understand, Griffin?
So you couldn't do like 3 squared plus x squared equals 8 squared and solve it that way?
Where do you have 3 squared plus, where do you have 3 from?
Well, if we cut that triangle in half,
I don't know. What if the triangle looked like this?
Okay, well then yeah, that wouldn't work.
I mean, we're not always bisecting the angle.
Okay.
I'm just drawing it like that, but that's not what we're always doing. We have to use trigonometry. We have to say then h is equal to 8 sine c, and c is 30. So now I can say this is equal to 1/2. Base is, what's the base here? It's 6, right? And h is 8 sine 30. What's sine 30?
Half.
Exactly. So the area of this triangle is 12. Use your trigonometry. I basically made that, I cut that down, I dropped the line straight down, which made this a right angle. Until it's a right angle, I can't do that, what I need to do. But now it's a right angle, I can use my basic sine, cosine, and tangent rules. Do you see that?
Yeah. I could use more practice with it, but yeah, that makes sense.
Okay, well, I think I have another one. Let's see. Let's do another one. I don't. You go back to this one. Yeah, let's do this one. Ready, Griffin?
Okay.
So let's figure out what we have. Now, again, my height now is going to be this, isn't it?
Yeah.
Okay, so now what can I do? So this is angle C. So this is C, this is A, and this is B. Okay?
So the h over 16.2
H
equals sine
over
28.3.
16.2 is equal to what?
Sine 28.3.
What's the sine? How do I get the sine? Here's my angle. The sine, you said at the beginning of class, sine is equal to what? Come on, Griffin, you know this. I know you're probably filling on the spot. So we have opposites, we have adjacents, we have hypotenuses. What's the sine?
The opposite over hypotenuse.
Okay, so what's the opposite over the hypotenuse?
This is just C over 25.6.
No, C is not opposite. That's not a right triangle. H makes my opposite.
Okay.
Because now I have a right triangle. Until I have a right triangle, I can't use those rules.
Okay, so H over 25.6.
Yes.
And then you get 25.6 sine 28.3
Exactly.
equals 8. H.
So basically, we can say the area is equal to 1/2 times, what's the base? Yeah.
16.2.
Times the height, which we know now is 25.6, times sine of 28.3. And whatever number that is the area. Is there anything here you didn't understand, Griffin?
Okay.
Okay.
I think
Does anybody else have a problem anywhere here? Is there any questions? Okay, so let's go back here. We have one more formula called Heron's formula. And Heron's formula works with all the sides. So if you only have side, 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 and no angles, Heron's formula is great. Basically, it's you have to find this first, so you add up all the sides, and you take half, and then the area is equal to this S times S minus each side. So for example, we have here a triangle whose sides are 3, 5, and 6. So first thing I have to do is find S, and S equals 1/2 the sum of all the sides. So this is equal to 11, 14, 7, right? And then that means the area is equal to the square root of 7 times 7 minus 3 times 7 minus 5 times 7 minus 6. So that's equal to the square root of 7 times 4 is 28, times 2 is 56, times 1 is 56, divided by 4. So 4 times 14, 8, so it's 8 times 7, so it's 42 times the square root of 14, I believe, if I didn't make any mistakes. So this is Heron's formula. It's nice and simple. It really is just memorized. I'm actually not sure how to make that all happen. If you need me to find out how to make this equation come true, I can. But it's more of a memory problem, I think, a memory situation. And